Today we are going to see an important chapter in the NEET physics session. What is that? Is electromagnetic induction. So what is electromagnetic induction? Electricity and magnetism, how it got induced, how the electricity and magnetism are connected together, what are the experiments to perform to show that how the electromagnetic induction is significant. So this is what we are going to see in this chapter of electromagnetic induction. It's an important chapter in the NEET physics session. So now before going for that electromagnetic induction, it was first gave birth Faraday, who gave birth to the electromagnetic induction. So what is the three experiments performed by the Faraday to show that how the electromagnetic induction is important. So first we go for electromagnetic induction. So what is electro here? Electricity. What is magnetic here? Magnetism. And what is induction there? Induction is a one connectivity. Induction is the connectivity. How electricity and magnetism are connected together. Yesterday I think in which chapter I told that electromagnetic wave. What I told you in electromagnetic wave? Electromagnetic wave. Both are perpendicular. So the electric field and magnetic field will be perpendicular. For example, if electric field lies in the x-axis, magnetic field will lies in the y-axis. For example, electric field will lie in the x-axis, magnetic field lies in the x-axis, electric field will lie in the y-axis. So both are perpendicular and mutually perpendicular. Mutual perpendicular means if any, it should be, if for example electric field lies in the x-axis, what is another one is electric field lies in the x-axis, magnetic field should lie in the y-axis or z-axis. Need not be y-axis. It could lie in the z-axis also, because x and y now both are perpendicular. So like that, that's what we discussed in the electromagnetic wave. So what we told, finally what we told that both are perpendicular. Now we go for electric field. Electric field y lies in the y-axis. Electricity lies in the y-axis. Electricity lies first one what we have taken? X-axis. Now we have to take electricity in the y-axis. If it is electricity lies in the y-axis means magnetism should lie in the x or z axis. So like that it has both are everything is perpendicular, mutually perpendicular. So this is what we feel this is what we discussed in the last class. So this is the continuity of this see all are continuity here. Law of motion, electromagnetic wave, electromagnetic spectrum, and electromagnetic thing, and in the things. So this electromagnetic, what is the seventh spectrum that we see in electromagnetic spectrum? Vibgyor, electromagnetic spectrum. UV waves, radio waves, etc. In that, which will have the highest wavelength and which will have the lowest wavelength? No, any one person. Which will have the highest wavelength? Radio wave. Which will have the lowest wavelength? Gamma rays. That means gamma rays or X-rays. Both are same, almost same only. X-rays we will take. Which will have the lowest wavelength? X-rays or gamma rays. Both are almost same only. Now here it is radio wave. Radio wave will have the highest wavelength. So if it is as the highest wavelength, what is mean by? What is the wavelength? Wavelength is a number of the waves that is needed time to complete one cycle. Okay, that's a wavelength. So that means for to complete a one cycle, the wave taking the time taken is a wavelength. Okay. Now radio waves has the highest wavelength compared to this wavelength. So this wavelength here it is lambda, here it is lambda. Okay. This one is lambda now radio wave lambda r. This one is lambda x. That's all. So lambda r is greater than lambda x. So what you so based on this spectrum only, we can see that how the application is variated. So this takes a lot of waves. That means time take what is the time here? Okay. Now lambda r is greater than the lambda x. Okay. This wavelength is short. Wavelength is larger. This one is wavelength is shorter. So the time taken for this will be, which one will have a higher time taken? Time taken will be which will take lot of time? Yeah, lambda r. Why are you blinking? Why you are blinking? Lambda will take a lot of time compared to this one. So based on this time, based on this only, now you go for 2. You need not go for 7, which will have higher and which will have lowest, because radio wave and X-ray and gamma is almost same. X-ray, this is a lower wavelength, this also gamma also lower wavelength, but almost similar. X-ray and gamma rays. So instead of taking gamma rays, I am going for X-rays. Okay. So now I am taking for, I got a fracture. Okay, I got a fracture in my hand or something. Okay, I will go for X-ray, not for radio wave. Okay, when I am using the mobile phone, I will use the radio wave. Okay, not the X-ray. So the application differs. How the application differs now here? Because based on the wavelength. Since this wavelength is shorter, what will happen? Yeah, it can. For example, I am taking that this particle. Okay, this is the fractured one. This is a particle which is one. Can we take how many? 1 meter square. Okay, just 1 meter, 1 meter. Bone. Okay, bone you can take, which got fractured. Bone. Okay, so the 1 meter versus 1 meter, bone is got fractured. What I have to see where the bone exactly fractured is. Now, 2 options I will give you. First option is that X-ray, second is radio wave. Yeah, everybody knows X-ray, radio wave. Okay, radio wave. Okay. Now, if I take this, which wave I will use here to find the bone fracture? Yeah, everybody knows that. Only X-ray can use, not the radio wave. Okay, but my question is that why you are using X-ray compared to radio wave? Huh? That's the thing now. See, I am going for a fracture bone. I am keeping, this is the X-ray. I am keeping my hand, which is got fractured. Okay, so when it's got fractured, what will happen now? I have to get my to see the structure. I have to see where exactly it is the